Hi guys, so am I audible and am I visible? I'll just check here if I'm audible or not. Am I audible guys? Okay. 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 So I'm just waiting. We'll just start at 7:05 or 7:06. So till then, if you have any doubt, like regarding the last class we had, or anything you want to ask me, then you can ask me. So today's topic is right here. Screen is not visible. Just give me a second. Let's see. If there is an issue. Okay. I hope my screen is visible now, guys. There are some problem. Okay, just hold on. I'm having difficulties here. I don't know what is happening here. Okay, so what I will do is I will just give me a second. I don't know what is happening. Okay, so I will just give me 2 minutes, guys. I will just start this video again. I think there is some issues. Just give me 2 minutes. Hello. Hello, guys. Am I audible now? And am I visible? Just tell me. Actually, there was some issue with my laptop. Am I audible and visible now, guys? Just tell me quickly. Can you please tell me if I am visible and audible? Okay, let me check. Let me check on my phone. So I guess I am audible now. You're audible, right? Okay. So just write yes in the chat if I am audible. Just write yes in the chat if I am audible. So I'm audible, I see. Sorry, guys, I got delayed. There was some issue. Now let's start with this topic. I already got a bit delayed. So let's now start. So what we'll do today is we'll be looking at this divide and conquer paradigm. We'll look at what divide and conquer technique is, how we'll be solving some problems using this technique. So we'll look at some classical problems today, some classical problems on divide and conquer, and I am sure you you guys know at least a few of these problems. Okay. So without delay, let's first start with this. What is this divide and conquer technique? So as the name suggests, divide and conquer means like if we are given a problem, we want to divide the problem into many sub problems, and then after and then we want to solve these sub problems. So after solving the sub problems, we want to combine these sub problems. That means like conquer the solution for this problem. Hi Jishan. Hi. So basically, it's like you can say like this, like we are given a problem of size n. Okay, this is given. What we want to do? Divide the problem into, let's say, a subproblems. Each of size n by b, let's say. Okay, and the last step would be, and now we want to, let's see. Okay. Now we want to solve the subproblem separately, and the final step would be let's say combine the results of sub problems. Get the answer to the problem. So essentially, okay, so can the audio be improved? Okay, so my audio is not quite good, right? Let me just check the settings. Now is it better? Now is my audio better? Just tell me in chat, is it better now? Anyone please tell me if the audio is better now or not? Okay. So I hope the audio is better now because no one is telling anything. Okay. So let's say now let's look at this thing. So what I actually mean by all these we just said. And here, so basically we are given a okay. So my audio is not good. I'm actually facing a lot of technical difficulties today. I got delayed because of some technical difficulty. I don't know why it is happening. So I will do one thing. I will maybe now please let me know if it is better. We'll just take the settings once again. If there is some issues. Should be just let me know now guys if it is better because okay no. So like am I understandable or still not clear? So what I will do is I will just remove this maybe. Okay. So now is it better? Now am I audible? I removed my headphone. So now just let me know. Lots of technical problems today I guess. I hope it is better now. Yes guys, is it? Okay, it is worse. Wow, so many problems. Let me do something. Let me check myself. Yeah. So is it now good? Let me do something. Let me check myself. So is it now good? Yeah, I think it will work right now. Yeah, I think it will work right now. Okay, so I will move ahead with this. What we're doing. So basically, what we're doing was like we are given a problem of size n. Okay, okay, just I don't know why it is something like this, right? Mm. I'm sorry, guys. There's lots of disturbance today. Lots of technical difficulties. So okay, so let's continue. So let's continue with this. Whatever is audible. So we are given a problem of size n. What we are doing is we are dividing the problems into a smaller problems. A smaller problems. Let me write in quotes. A is just notation, and each of the subproblems are of the size n by b. So here a means a should be greater than equals to 1 because we have to divide it into at least one or more subproblems. Okay, and here n by b, here b will be greater than 1. Why? Because because we have to divide it into subproblems which is of size lesser than n. So here b will be greater than 1. এটা ভালো না হেডফোনটা বেরাচ্ছে তো এটা না হেডফোনটা বেরাচ্ছে বেরাচ্ছে তাহলে হেডফোন না এটা So I'm extremely sorry for all these difficulties today. I think. Okay. So I will continue now, and I hope we have no more difficulties. So essentially, what we are doing here is we are given this problem of size n. We divide it into some subproblems of smaller sizes, and then we try to solve this problem separately. And finally, after solving those problems, we try to combine the result. So divide, solve the subproblems, and ultimately combine the results. Okay. So this is the fundamental rule in divide and conquer technique. Now this step you can write it as combine, or maybe you can write it as merge. Okay. So in some problems what happens is in some problems you can skip this merge step. Some problems just require you to divide and solve the subproblems, and then you can just get the result. in this merge can be ignored in some problems, but some problems will require it. So this merge is not a compulsory step. This is an optional step depending on the problem. Okay. So if we have understood this, so let's see some classic examples which you might know. I will not discuss the techniques, but I will just write the name. So some classic examples. So write examples of divide and conquer technique. So some classic examples would be like binary search, which everyone will know, I guess. So here you divide this problem into two halves of equal size based on some condition, and then you carry on the search on one of the halves. That means you divide the problem into size of n by 2, then you recursively solve the problem for the smaller subproblem, and finally you combine the result. That means you just return yes or no. So that is also a kind of divide and conquer. Another example which most of you know is merge sort. Merge sort is also a divide and conquer technique, and another example would be quick sort. So this merge sort happens. So what happens in merge sort is the first step would be dividing subproblems of size n by 2. Then it would be sort the halves recursively, like this left and the right half. That means left half containing n by 2 elements, right half containing n by 2 elements. Sort them recursively, like call merge sort recursively. Ultimately, combine or merge. Ultimately, we can combine or merge them. Okay, so simply like this is what we are doing. In quick sort also, same thing is happening. What happens in quick sort? In quick sort, a quick sort is an example where essentially we will not need this merge step. Like we saw, we don't need require this step everywhere. So quick sort is an example like that. Quick sort is like first you call this. So if you quick sort on an array, like if I say quick sort on array of size and indices are 0 up to n minus 1. So what you do, you basically find an index using this partition algorithm, right? You partition the array based on some pivot. Maybe not n minus 1, I will write this recursive. So I will write this as I and j in the form I and j. So I will write this as index I, which is L and R, left and right portions. You partition the array in two halves, like the partition algorithm. Then you recursively solve this left half and the right half. So you call recursively A N I N D minus 1, and again you call quick sort on the right half. Okay, so this is what is happening in quick sort, and in quick sort, this partition, this is basically the divide step. The divide. You are dividing the problem into two halves using this partition algorithm, and these are like the solving the subproblems. Solving the subproblem. Okay, and there is one more part, combining, but in quick sort we don't require this combining part, as we saw. In every problem, combining or merging is not necessary. So in quick sort, dividing and solving the subproblems is enough to solve this problem. but maybe it is required in some problems. So now we will look at the first problem for today using divide and conquer technique. So the problem we look at is this. Let's say so the first problem would be this. If you have any doubt till this point, you can tell me. Maybe you can write here, maybe I can write here as distinct integers. Some distinct integers, and we need to find our local maximum. We need to find a local maximum. Okay, so we are given an array A containing n integers, and we need to find a local maximum. So, what is the local maximum? So, a local maximum is an index I such that the previous element is less than that element, and that element itself is greater than the next element. Okay. Here, this I will lie between 1 and n. So you can write it like this. So if the array is like a1 up to all the way up to n, like in the n elements of the array. So like for any intermediate index, the maximum would be like an element where the previous element is smaller than it and the next element is also smaller. And there are some cases like if a1 is greater than a2, then 1 is a maximum, like a local maximum. And if the last element is greater than its previous element, n is greater than a of n minus 1, then n is the local maximum. Okay. So this is what the problem states. So given an array, you need to find the local maximum. So how do you think we can do this? How do you think we can solve this problem? If you have any doubt regarding the problem, you can tell me. How can you solve the problem, guys? Any idea? Anyone? Take your time. Think about it. So, any approach, guys, to solving this? Okay. So maybe what you can do is maybe you can do a linear search that take like a brute force. You already have a brute force method, and it would take linear time. Okay. But can we do better than this? Can we come up with something that can solve it in like faster than O of n? Is it possible to do that? So if I just minimize this a bit. So if we have something like this array, so to find the local maxima, like how do you think we can use divide and conquer to solve this? Okay, so let's first look at a very important thing. Say, like you have this condition, this should be made, right? These are things which should be satisfied. So if you have something like this, now let's see a very important thing. So suppose you are given an array containing the elements all the way up to n. Now, suppose we know that a of n by 2 is greater than, or maybe I can write like this, n by 2 minus 1 tau is less than a of n by 2. That means the previous element of the middle element is less than the middle element itself. Or maybe the other way around. Maybe this is greater than the middle element. So what can we say then? So if we know something like this, guys, just write in chat if I'm audible or not, or like if you have any doubt or not, because I'm not getting any response in the chat. That's why I'm saying. Is there some doubt in this point, or like in this point everything is clear, right? Okay, so if that is the case, so like for this problem, if we see, like we want to do it in something better than O of n. For that, like we need to come up with a very important observation, which we will see. So finding the local maxima is very easy if there is just a linear search. Linear search can do that, but if we can see a very important observation, then you see that we can do it in a better way. So if given this array, if we know that, if we are suppose we know that the previous element or the middle element is greater than the middle element, that means something like we have got this array, this middle element is 5 and maybe here it is, maybe this is like n by 2, let's say. If there is something like this, this is the last element actually, n. So then what we can say is, there will be, like there are two cases now. If the first element is greater than the second element, then what is the local maximum? If this is the case, then the local maximum would be 1, right? Like local maxima will be A1 because we know that it is a coordinate element, and this is the case. If that is not the case, if the second case is right, that A1 is less than A2, then what we can say, A1 is less than A2 means you have got something, some element like this, maybe 2, or maybe write it like array index only. A1 less than A2, and you have got some elements here, and ultimately you have got an element like a of n by 2 minus 1 and a of n by 2, and again elements follow, and we are given that this case is satisfied now. So this is greater than this. So if this is the case, so we can clearly see that there must be one maximum among these elements. There must be a local maxima among these. That means there must be an index I such that a of I minus 1 is less than a of I, and it is greater than a of I plus 1. Right? Like, is that clear, guys? Can you see that? So if you have something like this, so the array is like this, going like this maybe, and here it is coming down. So there must be one point, since all the elements are distinct, this is given in the problem, all the elements are distinct, then there must be an index I here, where, like, which will be the local maximum, right? We can say that, right, guys? Can you see this? Just write something in CAD maybe, if you have understood this. This is very simple, not very tough. So if that is the case, then we can say that there exists a local maxima in the array, right? So we can see in every array there will be at least one local maxima, because either the array is sorted in increasing order, that means the array will be like this, sorted in increasing order, then the last element can be the maxima, because the previous element will be less than this, or the array is sorted in decreasing order entirely like this, then the first element will be the maxima because second element will be less than this. Or if that is not the case, since the elements are not distinct, there must be one index such that this is satisfied. Okay, so let's now see how the algorithm actually works. So now we know that there must be a local maxima in this array. So I hope you can see this now, that this local maxima exists in the array. So what you can do essentially is take an example and see. That will make it more intuitive for you. So let's say we have some example like this, maybe 2, 3, 7, 9, and here 5, 3, maybe 6 here. So suppose you have an array like this, and you want to find the local maxima here. So how can you do this? So here there are how many elements? 8 elements, right? So the idea is that we divide the array in two parts, the middle and the second part, the first one and the second part. So just like division in binary search, we divide the array in two halves. So you know this, from this it is obvious now. So if I divide the array in two halves here, let's say, now I want to find the local maximum. So I check the middle element. The middle element I can say as 5 in this case, let's say. So let's say this 5 is the middle element here. You can take 9 also, no issues. So I see that the previous element of middle element, this 9, is greater than 5. So what you can do? Now we know that Since 9 is greater than 5, there must be a local maxima in the left half. Why? Because we have seen this, right? If we divide the array in two halves and the previous element is greater than the middle element, then there must be a local maxima in the first half of the array, right? So this is the property we are using. This is what we will use to solve this problem. So I check the middle element here with the previous element. If this is greater than this element, then I know that there is a local maxima in the first term of the array. So what I do here? So initially my search indices were low and high here. Now I know that my search space can be reduced only to the first half. So what I will do? So now I will reduce my search space here as high. Now I will search here. Now the middle element will be this. So you see that this 3 here is less than 7. So now if 3 is less than 7, that means like it is opposite case. The middle element will be somewhere towards the right half. Right? So it means that the middle element will be somewhere in the right half. So what I do is now I will check the right portion. So I will update this low to be here. This I was updated previously. Now I go to this element and I now check the middle element. Now this middle element you see is actually the peak element because this is greater than the previous element and also greater than the next element. So you see that this 9 is the peak element in the array. So do you now see how we can solve this? Just the kind of binary search, like kind of, but not binary search only, but like we are dividing the array in two halves in every step, and kind of based on the condition we go to the left half or the right half. So you can say, so I will just write what we did here was, so if I write what I did here, divide the array in two parts. A of 1 up to mid and A of mid plus 1 up to n. Now check if A of mid is less than A of mid plus 1, that means the, okay, so I will just write reverse here, or maybe you can write getter also, no issues, but since we looked at that, I will write since mid is greater, if mid is greater than the mid plus 1 element, that means there is a maxima in the left half. So I update, so I search the left half, that means I search from A of 1 up to mid. Else I will search the right half. Else search A of mid plus 1 up to. Okay. So we will search this mid plus 1 all the way up. So is it clear now, guys, how we are solving this problem? So essentially what we are doing here is we are given a problem of size n. So we are given a problem of size n, and at each step we divide the problem into two halves. So divide this problem into two parts. Now what we do, after we divide the problem into two halves, we either search the left half or either search the right half. That means we are based on some condition we are going to this left half or the right half. So we don't search both of these halves. So we can write the recurrence relation for this as T of n, the time taken to solve the problem of size n. So if you call this as search of 1 up to n, maybe, then you can call this as you divide the problem in two halves and you conduct the search in only one of these halves. See, you either search the left half or the right half. You don't search both of them, right? So if you search only one of them, so this will be T of n by 2 equals to T of n equals to T of n by 2. Just one searching. And to divide this what? You just need to find the mid. So mid can be found in just one operation. Mid equals to left plus right by 2. So that is just one operation. So you can write this as O of 1. So you can write the recurrence relation as T of n equals to T of n by 2 plus O of 1. And also there is no combining step here. There is no combining step required here. So if you write like this, now you can solve this and this will give you, so this is just like binary search. You know, in binary search we search in left half or right half. So this time complexity will give you big O of log n. So essentially we can bring down the time from O of n to O of log n by using this technique. So previously what we saw, the brute force way to find the local maxima was just a linear scan which would take O of n time here, as you can see. But using this technique, like how we saw, how we divided the problem in two parts and conducted search in only one of the halves. So using that, you can bring the time down from O of n to O of log n. So is there some doubt till this point, the algorithm we saw? I think it should be pretty clear by now. So if you have any doubt regarding this algorithm, how we solve this problem, you can tell me now. Otherwise, we'll look at the next problem for today. The next problem is also a very interesting problem, and that is a fundamental problem in divide and conquer. So if you have no problem with this, let's go to this problem. Let's go to the second problem for today. The second problem for today would be like the majority element. So what is this problem essentially? We are given an array containing 8 elements. Of elements. We have to find an element x in the array. Find an element x in array such that x occurs more than n by 2 times in the array. So let's look at an example which will make it clear. So we are given this array containing 8 elements. We have to find an element x such that which occurs more than, greater than n by 2 times. So if I take an example, maybe let's say we have an array like this, 2, 3, 4, 3 and 3. So I given an array of size 5. So you have to find an element in this array where the element frequency would be greater than 5 by 2. So what is 5 by 2 store? This is going to 2. So the frequency of the element should be greater than 2. Strictly greater than 2, not equals to. So here you can see that 3 is occurring 3 times. So here 3 is the majority element. Okay. So how do you think we can solve this problem? This is a very interesting problem in divide and conquer. So here you can apply divide and conquer in the like a very perfect way, I would say. So given this array of n elements, you want to find the majority element. So is the problem clear? First of all, tell me. If you have any doubt, you can tell me. So 3 is the majority element in this array. You can say. This is an example. If you just stop. So any idea, guys, how we can solve this problem? How we can find this element 3, the majority element? Any approach you have? Brute force approach, anything? So, we would like to solve this problem using divide and conquer technique. So one way can be, you can say, to find the majority element, what you do, you would like choose one element and search for that element in the entire array and count the frequency. So you have to count the frequency of every element and you just check if any element has a frequency like greater than n by 2. So that you can do using hashing. So you can use a hash map to solve this maybe, but that will take an extra space. We don't want to give any extra space for this. We want to solve this in O(1) space. That is the constant. So any idea how we can solve this problem, guys? I just want to know what you are thinking. How can we solve this? So let's first see the principal methods in here. The principal method will be divide, solve subproblems, and last step would be combine. These are the 3 steps which we know of our divide and conquer technique algorithm. So given this problem, try to think about it like this way: divide, solve subproblems, combine. So how do you think we can do this? Any idea, anyone? I will just give you some time to think maybe. So if you are thinking, just write what you are thinking in chat. Otherwise, what I do, I will solve the problem, obviously. Okay, so let's see. So a very important observation, which you need to find, like, so suppose you have an array of size n. Suppose you have an array of size n at here. Okay, so if you want to find the majority element in this array, the observation is that if you divide this array in 2 halves containing n by 2 elements each, then you need to see that if there is a majority element in this array of size n, then that majority element is going to be the majority element either in the the left half or the majority element in the right half. Maybe I should write that n by 2 floor and the rest of the elements here in the right half. So the majority element in the entire array is going to be the majority element either in the left half or the right half. So that is a very crucial observation which you should make. Let's take like any example just to see. So if you have like any array, like take a big array like this, 2, 3, 5, 2, 7. Okay, so what is this? 11. Maybe I will just put that, or maybe let's just reduce two elements. Let it do that. So how many elements we have here? 9 elements, right? And let's just, so we have got 9 elements here. So is there any majority element here in this array? There is a majority element, right? 2 is the majority element. So here the majority element is 2. So if you look at what we said, if I divide this array in two halves, let's say the first half contains 4 elements, second half contains 5 elements, then this 2 is going to be the majority element either in the left half or the right half. So in the left half, 2 is occurring how many times? 2 is occurring 2 times. And in the right half, 2 is occurring 3 times. So you see that 2 is the majority element in this right half. Maybe not in the left half, but in the right half it is the majority element, right? Because frequency of 2 is greater than 5 by 2 floor. That means it is greater than 2. So this is a very crucial observation which you need to find. If you get this observation, then the next step remains is how can you solve these subproblems recursively and how to combine this result. So, like to find this result, I need to find the majority element in either the left half or either the right half. Okay, my audio quality is not so good. Yes, I am facing some technical difficulties today. So, I will try to fix it next day. Let me see what went wrong today. I couldn't fix it now. But let's carry on with this problem. So, if we have this, now we know that we need to find either the majority in the left half or the right half. So, let's take this example only for our understanding, and it would make, like I would explain the solution to you with this only. So, let's say given this array, what you do, you divide the array in two halves. So one part would contain these elements 2, 3, 5, 2, and second part would contain these elements 2. So I have divided this array into two subproblems, first half and second half. Now I am dividing this array into two subproblems again, just like how we are dividing the array. Nothing difficult here. So dividing two halves. Okay. Now I again divide this array in two halves because like we will divide it like the smallest possible. So now this array contains 2 and this contains 3. Now what is the majority element in this array? The majority element is 2, right? So the majority element will be 2 in this case, and the majority element here is going to be 3, right? Okay. Now let's come back here. So I will just draw this like this. That will make things a bit more clear, I guess. So now when you come back here, so you see that the majority element of the left half is 2 and the majority element of the right half is 3. Now you cannot decide because the majority element in the left half and the right half are different. So you don't know what is the majority element. So what I will do, the idea is, I will consider that okay, 2 might be the majority element in the array. The majority element in this array. So what I will do, I will count the frequency of 2 in this array. Now I see that the frequency of 2 is 1. So it is not greater than not greater than is not greater than 1, right? Because there are two elements. If there are two elements in this array, the majority element should be at least greater than 1. Now I see that this 3 might be the majority element, might be. So I again see that the frequency of 3 is 1. So it is again not greater than 1. So neither of 2 or 3 can be the majority element in this array. So what I do? Now I understand that this array 2 and 3 doesn't have any majority element. So I will say is, I will return here, there is no majority element in this array. So I just return -1. There is no majority element. Now let's look at this left half, this right half. So if we solve this, 2 halves, 5, 2, best cases, majority element can be 5, majority element can be 2. Again, do this, frequency of 5 is 1, frequency of 2 is 2. So neither of them is the majority element. So what I can say, this array also doesn't have any majority element. This array 5 2. This array 5 2. So now when I go to this problem, now when I look at this problem 2 3 5 2, this array, so I see that there is no majority element in the left half or the right half. So there is no majority element in both of these halves. What I can say, that there is no majority element in this entire array. Like if in an array, if in the left half there is no majority element, on the right half also there is no majority element, then I can say that there is no majority element in the entire array. Okay, so I can simply say that there is no majority element in this left half. Okay, so the left half of the array has got no majority element, -1. Now let's come to this right half and see what we can do here. So I divide this in 2 halves. I will take some more space here and write it. And this left half contains 2 elements. Again divide them. Right half contains 3 elements. So divide this, and understandably it contains just 1 element. Again left half, right half. So now the majority element in this array is 7, right? And majority element in this array is going to be 2. So I return 7. 7 here. Now you know that the possible candidates for majority elements can be 7 or 2. Okay? So frequency of 7 is 1, frequency of 2 is 1. Right? So neither of them is a majority element. So again there is no majority element in this array 7 2. So this array is going to return -1 here. Now comes the interesting part. So if you look at this 3, this 3 is not the majority element, like the majority element here. So this will return 3. So 3 is the possible candidate for majority element, and this is going to be called on 2 and 2. And again recursive functions call them, break them here. So majority is 2 here, majority is 2 here. Now you see that it returns 2 here. So now comes the most interesting part. Now you see that both the left half and the right half has got the same majority element, which is 2. So if you say that both of them has the same majority element, then you can directly say that 2 is the majority element in the entire array. Right? Isn't this obvious? 2 is the majority in the left half, also in the right half. So this will also be a majority in this entire array, right? So you can simply say this 2 and this 2 are same. So I can simply say that 2 is the majority element in this case. So now comes the most interesting part. Now you see that 3 is the majority element of the left half and 2 is the majority element of the right half. So what you do in this array 322, this array we are currently considering, find the frequency of 3. So the frequency of 3 would be 1, frequency of 2 is 2. Now the array size is 3. So array size is 3 means 3 by 2 equals to 1, 3 by 2 4. So the majority element should have a frequency strictly greater than 1. So you see that the frequency of 2 is greater than 1. So you know that 2 is the majority element in this case, right? So I know that 2 is the majority element in this array 322. So what I do, I simply return 2 here. And the left half has a majority of -1. So now you see that the majority in the left half is -1. That means left half has no majority element, but the right half has a majority element of 2. The majority element in the right half might not be the majority element in the entire array. If the array like the left half has -1, right? But only the right half has a majority element of 2. So 2 might be or might not be the majority element in the entire array. So what you do, you simply count the frequency of 2. The frequency of 2 in this entire array is 72322 is 3, right? So you see that the frequency of 2 is 3, which is greater than 5 by 2 4. That means the size of the array. So you can simply say that 2 is in fact the majority element in my array, right? So the left half returns 2 now. Now the right half. The left half has -1, right half has 2. Right? If this is the case, what you do? Now it is simple, right? Now you see that left half has no majority element, but right half has a majority element of 2. So I just want to verify if this element 2 is the majority element in this entire array or not. So I will just count the frequency of 2 in this array. It is 1, 2, 3, 4, 5. So 5 is in fact greater than 9 by 2, the size of the array actually. That means 5 is greater than 4. Right? If that is the case, so I can say that this 2 is in fact the majority element in this array. So combining this -1 and 2, I actually finally get that 2 is the majority element actually. So can you see how we can divide this problem, like how divide and conquer can solve this problem? Finding the majority element in the left half, right half recursively, and then combining the result can give you this solution. So do you have any doubt till this point? You can tell me. You can tell me if you have some doubt. The algorithm is very simple, but a very crucial fact here is to identify that the majority element in an array is going to be the majority in the left half or the right half. That is the most important part here. If you can identify that, the problem is more or less solved. So what I can do now is I will just write the pseudocode, so that will make this problem more clear to you. So because let me just open this pseudocode. Let me just okay. So if you have understood this, how to find majority element, just tell me in chat if it is clear how to find this. Just write yes or no if it is clear. Anyone? Anyone? Is it clear, guys? Okay, so I hope it is clear. So now the pseudocode for this would look somewhat like this. Just a brief idea. So I want to find the majority element. This is called AB. in an array, and the left index is left and the right index is, let's say, L and R for simplicity. L and R. So how you would call this algorithm is, maybe the first call for this would be majority element of A 0 n minus 1. The standard procedure for dividing worker approaches. Like you pass the array and you just pass the initial and the last index of the array. So how do you find the majority element? So you have some cases like if L equals to R, that means there is just a single element in our array. So that element itself is the majority element. So we can just return A of L. One more thing can be if there are two elements in this array. Okay, not two elements. Two elements case is not required, I guess. So otherwise what I do, I divide the array in two halves. So I can write mid equals to left plus right by 2. Okay, I divide the array in two halves. Now what I do, okay, so my audio is not clear. Okay, so what I can do, I will just try to see if I can do something here. Maybe I would try to change the microphone and see. I don't know why it is happening today. Like last two classes, three classes I took, the audio was quite good. I don't know. Like, there is some technical glitches today. Now is the audio clear? Now is the audio clear? Now it is audible? Anyone? Is it audible now? It is better or still the same? Anyone, right? It is better now, the audio. Okay, no answer. Okay, good. I hope the audio is now better, I guess. So if the audio is better, let's continue. Now is the audio clear? Guys, tell me please. So if it is clear, let's continue. So what we are doing was, we are trying to find the majority element, right? So what I do, I divide this array in two halves. Now I am going to find the majority element. Maybe majority element, left majority is equals to majority element in the left half of the array from L up to mid, and you find the majority element in the right half, mid plus 1 to the till the right half. So you call this recursively on the left half and the right half to find both the majority elements. So if the majority element in the left half and the right half is same, that means the case which we saw here, both the majority elements from the left half and the right half are same. That means it is indeed the majority element in our array, in our current array. So if this left majority equals to right majority, I can indeed say that this element is going to be the left majority, means it is going to be the majority element also. Just return either of left or right, or else I have to do something, or else I will just find first the number of elements in our current subarray. See what are we? We found the majority element left half and the right half. Now just the combining part is left. Just the combining part. So how to combine these two results? That's what we are saying. So if both of them are same, just return them because that is the majority element. Otherwise, a combining can, I will first count the number of elements in our current subarray. So it's going to be L R minus L plus 1, number of elements in the current subarray. So if I can do this, I will write a function to count the number of elements. So let's call this left count. Left count is going to say the count of this majority element of the left half. That means left count is going to find the count of this left majority element in our array. So I will call this function on our current range with this left majority element. So what I do here is I make a function call, maybe let's say a function called count, okay? And right count is going to count the frequency of the majority element of the right half. That means count in this current range, find the frequency of the majority element of the right half. That means R majority. That means this element. Right? Now it is simple. Now if you see that the left count is greater than n by 2 floor, that means is the majority element indeed in our left half, just return that element. Or otherwise, just check if this right count is the majority element indeed in our array. Just return the right count. Okay. Otherwise, there is no majority element in our array. So let's just see this again. A very simple algorithm. Let us see. Okay, this count function is simple. This is nothing. This count is going to be a from L up to R with a value val, let's say. So just iterate from L to R, L up to R. If A of I equals val, you keep a counter called frequency, let's say. Update this variable, simply return the frequency. So it just counts the frequency of that element in the array, nothing else. Pretty simple function. So let's try to understand this once again. What we saw. I can change the name. Let's make this way. Okay. So what I did was I just a base case for our uh, like the algorithm. I divide this problem in two halves. Recursively find the majority elements in both the half, left half and the right half. If both the majority elements are same, if both of them are same, simply return that element as the majority element. If the majority element are not the same in this array, what I am going to do, I am going to count the frequency of this left majority element and the right majority element separately, because both of these can be the candidates for the majority element. So either left match or right match can be the majority element of our array. So what I do, I simply count this frequency of left match in this array, and I also count the frequency of right match in this array. So I stored them in these two variables. Now I see if the frequency of the left majority element, if it is greater than n by 2, simply return that, because that is the majority element of left half, like of the entire array. Otherwise, if the majority element of the right half is actually the majority element in our current array, simply return that, or else we have no majority element in our array. Just return -1. So that is the basic idea here. So do you understand how we can solve this problem? Is it clear? So just look at this problem we are solving. So is it clear how we can solve this problem actually? Just tell me if the idea here is clear, what I saw. And this is the initial recursive call. If you have any doubt, you can tell me now. Any doubt, guys? Okay. So no doubts. So let's see what will be the time complexity for this. So what will be time complexity? So we are given a problem of size n, right? Here it is called, let's say size n initially. We divide it in two problems of size n by 2, and you solve them recursively. These are the recursive calls of both the subproblems. So T of n equals to 2 into T of n by 2 plus what is the combining step costing. So after you find the majority element of both these halves, if that is the case, it is simply O of 1. Otherwise, we have to call this count function. This count function for these elements, and count is going to take how much time? O of n, just a linear scan of the entire array from L to R. So count is O of n time. So combining it is this step. This step is the combine. Combine is 2 into O of n, which is nothing but O of n actually. This is a combining step here, and depending on these cases, you can simply return this or -1. So essentially, we say we divide the problem in two halves, solve the subproblems, and combine the results in linear time. So this is the recurrence relation for this algorithm. So what will be time complexity for this? Anyone? What do you think will be the time complexity if this is a recurrence relation for our equation? This you can say as big theta of n or big O of n. So this will give you O of n log n. Isn't this the recurrence relation for merge sort? Like in merge sort, this is the recurrence relation, right? 2 into n by t of n by 2 plus combining is O of n. So this will be the time complexity for this problem. So any doubts till this point, guys? Otherwise, let's look at like another problem. Let's see another problem on divide and conquer. No doubts, right? Okay. So if you have no doubts, let's go to the next problem. Okay. I'm actually facing a lot of technical difficulties. I don't know why it is happening. I even can't change the color. Wow. Okay, let's see the third problem. Okay. Let's say the third problem. So in this problem, we are given an array of size n. So what I do for every element of the array, find the number of elements on the right side which are smaller than that element. So if you are given an array like this, let's say an example 5 2 6 1, your answer should be the number of elements smaller than 5 on the right side is 2 and 1 are smaller, right? So this will be 2. Number is smaller than 2 is 1. Just 1 is smaller. So 1 element is smaller. For 6, only 1 element is smaller. 1. For 1, there is no element smaller than 1 on the right half of 1. So this will be your result. So if the array given was like 5 and 5, your answer would have been 0 and 0. Just because no element is smaller than on the right hand. So is the problem clear, everyone? So is the problem clear, guys? Tell me if the problem is clear. Okay. So if the problem is clear, so how do you think you can solve this problem? How can you solve this problem? Any idea? Anyone? For every element, you need to find the number of elements on the right which are smaller than the smaller than. So this would be the result for 5261 211 2110 will be the result. Guys, tell me if you have any approach. Think about it. Take your time, take 5 minutes, try to see. See, now we have looked at two problems already on divide and conquer, and these are pretty standard problems. So just to give you a brief recap what we saw today. So first of all, we saw this local maxima element, like local maxima. We found the local maxima in an array. So the brute force was O of n, that's a linear scan, but using this divide and conquer technique, what we did, we essentially brought down the time from O of n to O of log n. This is a very standard example of divide and conquer. Now next we looked at this majority element problem. Like majority element problem, this can be like the brute force would be 2 of n squared, taking every element with every other like the frequency. Or maybe hashing can bring it down to O of n, but the space would be O of n again. But using this algorithm, like dividing of algorithm which you saw, we brought down the time to O of n, and space was just log n because of the recursion stack. But time we brought down to O of log n, and space was also optimized to log n. In interview, if you are given this question, you would be asked to solve using divide and conquer, because everybody would be come up, like everybody can come up with this hashing algorithm, but this divide and conquer algorithm, it is a bit difficult to come up. The interviewer will tell you maybe you can take some more time, like maybe not O of n, O of log in log n of or O of n square, but do it using divide and conquer. So this is a very famous problem in divide and conquer, and it has been asked in interview several times. So now this is the third problem for today. Given this array, find the number of elements. For every element, find the number of elements towards the right which are smaller than that element. So how can you solve this, guys? Any approach, anyone? Write in the chat if you have any solution in your mind. Write in chat. If you have any idea, like how can I solve this, write in chat. I will just give you 2 more minutes to think about the solution. So, okay, write anything in chat, your approach, how you can solve this. Try to interact, guys. So I will just solve this problem, no issues. But I would like you to think about it. Like again, remember 3 points we saw in divide and conquer. What we saw here, first step, divide into subproblems. Solve the subproblems and then combine. So this is the basic funda of divide and conquer technique. Combine the results. Okay. So if you are given this problem, I would give you a hint. I would give you a hint. Try to think from the point of merge sort. You know what is merge sort. They given an array, merge sort left half, merge sort right half, combine the result. Try to think in that respect of merge sort. How can merge sort be useful here? Any idea? Anyone? How can you come up with the, how can merge sort reveal the number of elements smaller than that element in the array? Actually on the right side, this is also very important, on the right side. Any idea? Anyone? I'm waiting for some answer. If I don't get an answer in the next 2 minutes, then I'm going to continue with the solution. I'm just giving you some time to think. That's it. Okay, so I guess I should go with this how we can solve this, right? So what I would expect is that I expect that most of you know what merge sort algorithm is, right? All of you know what merge sort is. Write in the chat yes or no. Okay, so if I hope that everyone of you knows what merge sort is. So suppose you are given an array like this. What you will do in merge sort, you divide the array into halves and you solve them. Let's say you have already solved the problem. Let's say you have sorted this array already. Like using the merge sort procedure, the standard procedure of merge sort, we have sorted this. Okay, so you call the merge sort recursively, you merge them, and now you are at this position 1, 2, 6 and 2, 3, 6. The right half, left half, and the right half. So now it is the combining step. The now given this left half L and R, let's say, now you want to combine this. Combine. So how can you combine this? How can you combine this? And during this combining procedure, you want to do something useful work so that you can somehow reveal the elements which are smaller than an element on the right half, on the right side. Somehow you want to reveal that using this combining step. What is the idea which you can use? Okay, so I will just tell you. So what we can do here is, first of all, we keep two pointers here. We keep pointers here. First, we see that one is a smaller element. So let's go slowly and try to understand this. First of all, the number of smaller elements for every element is zero. Zero here, zero here, zero here. Number of smaller elements on the right side. Every element is zero. Now I just do the standard merge sort procedure. I first compare the first two elements. I see that one is smaller. One is smaller, so put one into our sorted array and increment this pointer. Now you see 2 and 2. What I do here, if both the elements are same, I am going to give priority to the element on the rightmost side or on the right side. So what I do, I put the element from this side into our array and I go to the next element. Now again 2 and 3, 2 is smaller, I put 2 first. Now 6 and 3. So now comes the most important part. So I put 3 here and now I see there is 6 and 6. So again I give priority to the element on the like the rightmost side. So I put 6 there. Now it is the most important thing which comes. Now see this. Now I have got, now what I have got here? I have got 6 here, right? So if you see, the number of elements smaller than 6 on the right half is what? This 2 is smaller and this 3 is smaller, right? So now from this array we have already put 2 and 3 which is smaller than this element 6 in this array. So you know that there are two smaller elements than this 6 in this right half, and then you finally you increment this by 2 because there are two smaller elements here, 2 and 3, and you finally put this array, this element 6 into this array. So you merged this entire two arrays, this left and the right half, you merge them into one single array, and during that time you also uncovered the number of elements which are smaller than that element. So is the idea like you can understand it what we are doing? So okay. So if you have any doubt you can tell me in chat. So what I will do is I will just try to explain it using a smaller example maybe. So let's take the example we had initially, like this array. Try to understand it very clearly. If you have any doubts in any point, tell me. So given this array, 4 elements, divide the array in two halves. 5, 2, and the right half containing 6 and 1. Okay. Now divide it furthermore, 5 and so what I do now what I do is I see that in this array, so but I see that now this is just a sorted array, this is sorted. So I have to combine this 5 and 2. So now the combining portion. Now how do I combine them into a single array? To combine them, what I will do is I will see there is 2 here, 5 here. So 2 goes first. 2 will go first from this array, and then 5 will come. So you see that on the right hand side of 5 there is one element which is smaller than 5. So you see there is at least there is one element towards the right of 5 which is smaller than 5. So you increase the frequency of 5 by 1 and 2's frequency is 0. Now go to this left half, divide this array, 6, 1 here. Okay, now the combining step. Combining just two elements here. Okay, so what is smaller? How do I combine this array, like these two arrays into one array? 6 and 1. I see 1 is smaller. So let's put 1 here and increment 1 here. Now 6 is here. So what I do? Now I will put 6. But before putting 6, I see that on the right array, on this right array, this array right side array, I already have one element inserted into our merged array. So there is already one element which is smaller than 6. So I will increment the frequency of 6 from 0 initially to 1 now. And this was 0 initially, so it was 0. So I say there is one element which is smaller than 6. So I put 6 here and I increment the count of 6 to 1, and also the count of 5 is 1 now. Okay. So what I can do now? Why is this not working? Okay. Guys, excuse me. There is some technical difficulties I'm facing here. Okay. So this is what we have now. Now we are done with this. So we now have these two arrays. 2, 5, the left half, and 1, 6, the right half. And the initial array we had was 5, 2, 6, 1. I am trying to explain you, like I cannot erase them, so just bear with me. I hope the logic would be clear to you at least. So now the frequency of 5 was 1, we saw here 1, right? Because the number of elements smaller than 5 was 1. And also for 6 it was 1. And it was 0 here. Now we have these two arrays. This left half with 2, 5 which is already sorted, and the right half 1, 6 which is already sorted. Now I am combining these two into one array. So combining step is very important. That is the step which reveals the number of elements smaller than an element. So I combine 2 and 1. So among 2 and 1, what is the smaller element? 1 is smaller. So I put 1 here and I increment this here. So now there is 2 and 6. So among 2 and 6, what is the smaller element? 2 is smaller. But while 2 is smaller, you see that we have already put one element from this right half into our merged array. So there must be one element which is smaller than 2, right? That is obvious, right? So I increment the frequency of 2 to 1. Okay, and I put this element 2 in the array, and now increment this pointer. Now 5 and 6. 5 and 6, which is smaller? 5 is smaller. 5 is smaller means I will put 5 in this array, but I see that there is already one element from the right half which has been already put in this merged array. So one element was at least smaller than 5. So I increment this count of 5 by 1 again. So it will be 2 now, right? And then we put 5 here and it goes out of range. Now we put 6 back. From the right half array, nothing to do. So ultimately the array is combined, the array is merged. Okay, array is merged, and the ultimate count of these elements are 2, 1, 1, 0. That means just write here 2, 1, 1, 0. The required array, right? So is it clear, guys, how we can do this? So have you understood how we are trying to find the number of elements smaller than the element in the right half using this, just this merge sort, just the merge sort procedure. So is there some doubt? Like anyone, any doubt? Write in chat, or if you have understood what I am trying to say, just write yes, understood. Or if there's some doubt, you can write also in the chat. Like put your chat in the doubt. Then what I will do is I will just show you the pseudo code, like how easy it is, like how we can easily modify the merge procedure of the merge sort algorithm, and this will become easier for us. Any doubts, anyone? Tell me. Or just write yes, understood in chat. I would expect some response. The minimum you can do is respond, right? Just respond with yes, understood, or write your doubt in the chat. Okay, so I have got no response. That's fine, no problem. Voice is not clear. I am. I actually tried to fix this, like right from the beginning of the class, but I failed. I'm trying to fix this. I tried all the microphones available. Actually, it was working. The previous day, like I had 2 or 3 more classes on YouTube, and it was working like perfectly in those classes. But today, I don't know why it is not working. I tried all these microphones available here. I tried to put them and just try to see if it's clear, but nothing seems to work here. Is it better now? I'm trying with all the microphones. Is it better now? Or I will try with the next one. Is it better or bad than the previous one? No. Okay. I will do this maybe. The default microphone I have. It is bad now. Okay. Okay, just give me a second. What I will do is I will just use a different microphone maybe. I will just change my microphone. Just give me a second. Different headphone. So I will just try with this microphone. Does this seem better? See, I changed the microphone. I changed my headphone. I put in a different headphone. Is it better now? Okay. I'm very sorry for this. Like I tried all this. I tried everything possible, but it doesn't. So what I will do is next day I will just check beforehand and see what is the problem. But today it will be difficult now to fix this. So if you understood this, I hope you understand logic at least. I will try to fix it next day. Okay. It is not possible to fix it now. Full echo. Okay, man. Bad. Too bad. So just bear with this. The audio is bad. I'm very sorry for that. I will try to fix it next day. But let's go back to this problem. What we're solving. Let's go back to the problem. Yes. We'll continue with this class. So if this algorithm is clear, what we saw here, so I will do is I will just write the pseudocode for this. The does the merge procedure, and then we see how simply if we change the merge procedure of merge sort, we can do it better. Like we can solve this problem. How the merge sort algorithm, the standard merge sort, which you already know, can be used to solve this problem. Just repeating the problem, you have, for every element in the array, you have to find the number of elements on the right side which are smaller than 10. So how merge sort can be used to solve this problem? So what I will do is, let's look at this merge sort procedure. So what you do in merge sort, in merge sort you are given an array with the left and right bounds. What you do, you just check if left is right, less than equals right. You divide this array in two halves. A plus R by 2, and you merge sort the left half and the right half, right? Then up to M, and you merge sort the right half. A plus 1. Now comes the most important merge procedure, which we'll modify today, and we'll see how merge procedure can be used to solve this. Okay, just simple merge sort, which everybody of you know. Now let's look at how we modify the merge procedure today. So what I do here is, first merge does is we just merge the arrays like A of L up to M and the array A of M plus 1 up to R. Okay. So these two subarrays will merge. So first number of elements in this left subarray is M minus L plus 1, and on the right subarray is R minus M, right? Number of elements here, let's say this as N1 and this as N2. Okay. So I have to create a new array. Let's call this array as B. Okay. Let's call we have an array B from L up to R. That means of size, I'm taking just a new array, nothing else. R minus L plus 1. Okay, this is the size of the array. So now comes the most beautiful part here. So I will keep a count variable here. Maybe let's call this frequency. And one more thing I have to say, that initially we have this array A. For here, let's say it was but it was 5261, right? 5261, and we also have another array called as count. Initially it is 0000. The array which will store the count for every element. Let's call this two as global. These are global, okay? These are global arrays, just for your understanding. So we have these arrays already defined, A and count. So if I use A and count anywhere, these are defined. So I am passing here, no issues. I hope we get these. So this is the frequency. Actually, it's let's run this. Okay. So what I do now is the combine step. So how do I combine this array, guys? I keep an index variable to 0, and I keep two pointers to the first array and the second array. The pointers can be written as I and 0. I equals to 0, j equals to 0. So this variable is which we will be using to count the frequency. These two are normal merge sort variables we use. So while I maybe yes, maybe I will just write this as L and J as A minus 1. Nothing but the first elements of the arrays. These are this. Okay. Just for easier implementation, nothing else. So while I less than what? Less than equals to M, and J less than equals to right? That means the bounds. I check which element is smaller. If A of I is less than A of J, I check the elements of the two halves. So I is pointing here, let's say, and J is pointing here. If the array of the left half is less than the array in the right half, you simply put this element into this array and also increment the count of this element, right? So I will do is B of I and D equals to A of I, and also this frequency variable which we are using, you saw during implementation. I will do is count of this element I at index I will be incremented by frequency, okay, and also you increment this by 1 and increment this I plus equals to 1, okay. Otherwise what we do, this is very interesting. Otherwise the element on the right half is smaller, right? The element on the right half is smaller or equals to, maybe I can write here as AI less than equals to, the element is less than or equals to the element on the right half. Otherwise this is just nothing but AI is greater than AG. Right element is smaller than this element. So what I do, our next candidate is AJ. B of index is going to be the element AJ, but we don't increment the count here. Why? Because it is already in the right half. So I cannot know anything about number of elements smaller than this. For the elements of the left half, I know some elements are smaller than this, right? So what I will do here, I will just put this element here, and I will do is, what I will do is frequency will be equals to frequency plus 1. This is the step which we use. This variable counts the number of elements from the right half which we have already put into our merged array. This is the step which we are using to count the number of elements which is smaller than the elements in the right half. So I know that already some elements have been, like frequency elements have been put into this array, right? And then just increment the index and increment the j. Normal increment I and j, but this frequency as and when, so if the arrays were like, I would just explain it once, like 5261, like the arrays were, I will just explain here for better understanding. If the arrays were like 52 and 61, the second array, this is the first array pointed by I, this is the second array pointed by j. So what I do, I first check this 5 and 6. 5 is smaller, first frequency is going to be 0, right? Initially it is 0. I just put 5 here, do nothing. Okay, sorry. The arrays are going to be sorted. Okay, because we are sorting it, right? Did you understand what mistake I made? The array should be sorted. So the arrays will look like 2516. The arrays are already sorted, right, guys? This merge sort procedure is already sorting the arrays, this and this, and after that we call the merge procedure. So the arrays are already sorted. And let's say initially the frequency variable, which is FREQ, which is saw, this 0. Now pointer I is here, pointer j is here. I say that this element is smaller, 1 is smaller, so I append 1 into our array and I increment this variable by 1. That means this case, right? This case, ai greater than aj. This is the case. So I put 1 in the array and I increment the frequency variable by 1. That's it. And also I increment j. Now I see that 2 is smaller than 6. So what I do first, I increment the count of this element by frequency. So count of 2 at this point was 0. Now this is going to be 1 because 1 is smaller than 2. So now I increment the count and put this element 2 inside it. Now I moves here. Now at this point, if you remember, the count of 5 was 1 and count of 6 was 0. It doesn't matter. Count of 6 doesn't matter. Count of plus 5 matters. So at this point, count of 5 was 1. So if you do it, now you see that 5 is smaller than 6. So we'll just append 5 into our array and increment the count of 5 by this frequency variable, which is 1. So it becomes 1 plus 1 equals 2. And finally, I moves here and you just put the elements of the right half into the array. So ultimately, you see that the frequency here is updated to 1 and 2. That which means that this element 1 was actually considered now. Because 1 is less than 2, 1 is also less than 5, and it is in the right half of the array. Right? 2, 5 is left half, 1, 6 is right half. 1 is on the right half and it is less than both of them. So that is one element where ai is greater than aj. So do you see how how the merge procedure can be used to uncover the number of elements which are less than that element? I just do simply keep track of the number of elements from the right half we have already put in this array. If we just keep this track, it is very simple. And after this simple merge procedure, if there are some elements remaining from this array, what you do? Just put them into this array, and also you have to increment the count, right? Count should be incremented by how much? Frequency, because it is the left array. That is why you are incrementing the count. For the right half, we don't increment the count. And ind plus equals to 1 and maybe I plus equals to 1. Also for the left half, standard merge procedure, while j less than equals to r. Right half, b of ind equals to a of j and ind plus equals to 1, j plus equals to 1. Here you don't need to update the count because these are elements from the right half of the array. So for them you don't update the count. You only update the count for the elements of the left half. This is the left half. This is the right half. So now look at this once. How we solve this simple merge sort recursion. This procedure is we just added two lines. Just we added this variables frequency to keep a count of these elements of this merge procedure. For all the elements on the right half, we keep track of how many elements of the right array we put into our merged array, and when we are putting an element from the left half of the array into the merged array, we simply increment the count of the element by the number of smaller elements. Okay, and if some elements are left, we again repeat that procedure. Here you can increment frequency also it doesn't matter because your job is, because frequency is only used here. It doesn't matter if you, or here, it doesn't matter if you update frequency or not. This step you can ignore also, like not a big deal. So is this procedure clear? How we are, how this March procedure of March sort can help you unravel the number of elements more than an element? This is very interesting. Like, you know March sort, everyone knows March sort, but this is very tricky, right? Just modify it a bit, and March sort can be very useful. The March procedure can be used to do like some interesting things. So just tell me if this pseudocode which I just wrote, if it is clear. Is the pseudocode clear? What we did here, I just modified this March procedure. I just added two lines to it. Just add two lines. This line maybe, and this line and this line, and nothing else. And our job is done. Isn't it interesting? Very simple, right? Tell me in the chat if it is clear. So this was the problem. Count the number of elements on the right side which is smaller than the element. Okay, you can just reply in chat if you want. Otherwise, I will just tell you a very interesting, like some interesting things. Like, you know what is an inversion? An inversion. An inversion is a pair of element, is a pair of indices ij such that such that I is less than j and a of I is greater than a of. That means I comes before j and the element ai is greater than the element on the right side. So this is called inversion. This is what should be satisfied. Now, isn't this an inversion? For every element on the of the array, find the number of elements on the right side, which are smaller than that element. Isn't this an inversion? Basically, for every element, we need to count its inversion. The number of elements on the right is smaller than that, right? Is it clear, guys? Just tell me something. Okay. So, for every element, I have to find this inversion. So now there is an extension of this problem. I will just tell you the problem, and you will be able to solve it on your own. Like this. I will not solve this problem, but I know that you will be able to solve it on your own. Given an array A of size n, count the number of inversions in the array. So now you know what inversion means. Basically, you have to count number of pairs of indices ij such that this is satisfied. I less than j and a greater than aj. So if you have So if you look at the array which we had initially, five, two, six, one, the number of inversions would be how much? 4, right? For 5, the number of elements smaller than it was the right are 2 and 1. For 2, number of elements smaller than it are 1. For 6, number of elements smaller than 6 is 1. So here, here it is 2, here it is 1, here it is 1. That means 2 plus 1 equals to 4. Can't you solve this problem? If you can solve this problem. So these are two problems which are related to this. That's the same concept, just like a minor modification. So if you can solve this problem, I would expect that if you understood this, how to solve it, I would expect that you can solve this also. And if you can solve this, just write in chat, yes, you have understood how you can solve this. This is the final problem for today, which we saw. So is it clear, guys? Can you solve this problem now? Given that we have solved the previous problem, the previous problem. So what is it? It is simply the sum of all the array elements, right? After you find this count array, what if you do? Your result is going to be simply the sum of all these elements. This is going to be your result, right? The total number of inversions in the array. So these two questions are asked in interviews. Either they will ask you the first one or they will ask you this one. But whatever it is, if you know to solve one of these, you should be able to know like how to solve the other. So I hope you learned something today. I will just give you a brief recap of what we saw today, just so that you know what we did today. So we first saw this divide and conquer paradigm, how we solve this problem. We solve the problem, divide the problem of size n into a subproblems of size n by b each. So if you write the recursive relation for this, it will look somewhat like T of n equals to a subproblems, right? A subproblems. So a into T of each subproblem size is n by b. So you solve this subproblems recursively and solve this. To solve this, the time taken would be this a into T of n by b. And the combined step is going to be, let's say, a function of f of n, function of the input size n. So it can be O of n, O of 1, O of n square, anything depending on the problem. This is what varies with the problem f of n. So this is a general recursive relation for any divide and conquer problem which you will see. So these are the very fundamental divide and conquer problems: binary search, merge sort, quick sort. Then we look at this problem of finding a local maxima. A local maxima is nothing but an index which is greater than the elements on the left and right side, or just the left and right side, or maybe the first element or the last element, some special cases. Then we look at this problem, the problem of finding the majority element in an array. The majority element here is an element which occurs more than n by 2 times in the array. More than n by 2 times in the array. We solved it using divide and conquer. We saw how to come up with this algorithm, and we came up with an O of n log n algorithm. Okay. Then we looked at this problem of finding for like the inversion, finding the inversion. For every element, count number of elements on the right which is smaller than it. Nothing but an inversion. So you look at this problem, how we can use the simple merge sort which you have known all the time, how you can simply modify the merge method of this and solve this problem, how merge sort actually unravels the number of inversions in the array. Then we look at this, just a minor modification of this, you have given an array, you have to count the total number of inversions in the array. I think, I hope like you learned something, like you learned how to come up with these divide and conquer methods, how to divide the problems, how to combine them. So I would end the session with this. If you have any doubt, anything you want to ask me for all the problems which we saw today, you can tell me. If you have any doubt regarding any problem which we saw, you can tell me now. Okay. If you have any doubt, guys, tell me in chat. I am following your chat. I will be happy to clear your doubts. Like any doubts on the problems you saw today. So these problems you can also find a lead code like majority element, count of smaller elements on upper self. You can find them on lead code. Just search on lead code and you will find them there also. Okay. So what I do is I will just, if you have no doubts, then I will just tell you about the current courses we have on Unacademy, because like this might be very much helpful for you if you are preparing for interviews. This can be very much helpful for you. So we currently have these batches like Transpire. This is actually a batch which will teach you about the fundamentals of computer science, like OS, DNS, and computer networks, which is asked like in all interviews, like on all PSD interviews you can see. They will have one round related to this. Then we have this Ecologia batch, which is a beginner batch on Java. In 7.5 months, you will learn from the basics of Java and you will go to advanced, like implementing all these algorithms and data structures in Java. So this is a complete beginner to advanced course. And we have this Brahmastra course, which is a 5 months course for interview preparation, like for off-campus and placements, like college placements, both of them. So these are 5 months course on interview preparation. If you are currently preparing for interviews, it can be helpful for you. Now we have this Mahayada course, which is a 6 course on advanced programming topics. Like we will be covering mostly the advanced topics which are asked in ICPC, or like mostly about the advanced topics which generally for it is mostly for 4-star or 5-star programmers who are looking to learn something advanced. So this is the duration of these batches. So transfer will start on 28th July. Like they will start like in this coming week only. Ekalabhya will start on 21st July, Brahmastra again on 20th July, and Mahayata again on 28th July. Okay. So these are 1 month, 7.5 months, 5 months, and 2 months course. So if you are interested in joining these courses, so why will you be interested in joining these courses? So the benefit here is that they have a structured learning path. So what it means is that before you join the course, you'll be given the entire syllabus of what will be covered in these courses. You will get to know like which topics to follow step by step, like one after another. It is not like any random, like some random YouTube videos. You go and search this topic and watch it. So like everything is in a structured manner. So you have a path to follow. And if you just subscribe for this Unacademy course, you will get all these batches. That is the way you will get all the courses and batches here, and they will help you prepare for the competitions like ICPC and Core Jam. And also, if you are preparing for drug-based companies interviews, they will be helpful. And you will learn from some of the best coders in India, as I will show it to you soon. And also, the fees is very less, like less than rupees 90 per day. Just with a nominal fee, what you'll be getting is quite low. You'll be like solving interview problems, and after 5 months or 4 months, you'll be getting a good job. So it is a very small investment in that. So I just show you the syllabus of these courses. So here we're going to cover computer networks first. Then we'll go to DBMS and relational database management system. Then we'll look at operating system. It will give approximately 1 month for each of these subjects. And finally, we look at object-oriented programming in last 2 weeks, and we look at some principles and also implementation. Then there is this Ecologia course, which is on Java, from basic to advanced. The syllabus mainly covers the first will cover the introduction to Java programming. Then we look at implementation of sorting and searching. Then some basic fundamental data structures for interview problem solving. Then we move on to some additional concepts. Ultimately, we go to greedy algorithms. Then you can see current decomposition, tries, segmentation, some advanced topics we will solve after this. Then you have got number theory and interview problems, recursion, dynamic programming. Then we have graph algorithms with a lot of problem solving. Like these are mainly focused on problem solving. Okay. Then we have this Brahmastra course. The Brahmastra course is mainly for interview preparation. The syllabus is, you can look at the syllabus here. The maths and puzzles in the first 2 weeks. Sorting and searching, very important topic, bit manipulation, backtracking. Then we look at some basic data structures, extensive problem solving, string algorithms, greedy algorithms, advanced dynamic programming, graph algorithms, and at last we look at the most asked interview problems in the top problem summary. So we'll be looking at all the interview problems which are asked in this last 2 weeks, and they will be and you will be taught by those who are working in this company, and they also take interviews actually. So you'll be learning from those who might be taking your interviews in the future. You don't know. Now, my other is a 6 week course on advanced programming. We'll start as some advanced programming with some tough concept, like conceptual problems, like how to approach those problems. Then we look at segmentaries, advanced segmentaries actually. We solve a lot of problems and look at some complex use cases. Then we look at advanced graph theory concepts, and then we'll have 1 week on problem solving on mixed topics, like where you have to combine all these topics and solve problems. So these are some of the educators we have, some of the best educators in India. We learn from them. So every class is live class here in Unacademy. You don't get any recorded videos. So whatever you will be learning is from live classes, and you will get doubt support. If you have some doubt after the class, you can ask in a dedicated Slack channel about your doubts. You also have relevant practice problems, of course. Okay. So these are the profiles of the educators we have. You can look at their profiles here. They're like working in top broadcast companies, or they have been to SA Magazine World Finals. So you have to look at their profiles. Some more educators we have here. Some of the best educators in India. So now, if you want to register for this course, this is a this is the fees for 6 months, and this is the fees for 12 months. See, it is a very nominal fee if you consider the benefits you'll be getting after like 6 months or 12 months. Like you'll be getting a job in a top broadcast company. So it is a very nominal fee. You have to pay for that, and you are getting all the courses like data structure, system design, like, and there are many backend and front end courses also you can register for them. Like one subscription, and you can register for all these courses. So you can use my coupon code to get a discount of 10%. The coupon code is Arkapravo Ghosh. I will just write the code in chat so that you can use it if you want. So you just write the code in chat so that you can get it. So upon this fees you will get 10%. This fees is without discount. Okay. You will get an extra 10% of this. Okay, so let's now let's now end this session. I will be here for 1 more minute, just so that if you missed any doubts you had, you can ask me. Otherwise, you can ask me your doubts in the next class also. I will be having a class tomorrow evening, most probably. Okay. I will be having a session on leak list interview problem solving tomorrow. If you have any doubts, you can ask me now. Or else, you can ask me tomorrow also. So if you have no doubts, I will be ending this session here. So I hope there is no doubt at this point. Okay. Goodbye, guys. Take care. We will meet tomorrow in the evening. Okay. Goodbye. Good night.